Hello everyone, welcome to day 31st of August LeetCode challenge, and today is the last day of the August challenge, and the question for today is delete node in BST. It's a typical interview question that is very frequently asked in interviews. So let's go through the question and let's discuss the approach. Given a root node reference of a BST and a key, delete the node with the given value in the BST. So you need to search for a particular node, and if that node is found, just delete it from the tree and return the new tree. Let's go through the examples. So this is a tree given to us, and he has told us to. The question has told is to in the question it is told to delete the key with three value. So we have to delete three. We found three key, and we updated the tree and we returned this. Another valid answer would have been this. Yeah, both make sense. So let me just talk about the solution now. The question is an amalgamation of two problems. One is a searching for a particular key, and other is an in-order successor of the particular key. So if you know these two questions beforehand, it will be very simple for you to understand the solution, since deletion is nothing but a combination of searching and in-order successor. Why I am saying this, let me just jump on to a few cases and you will understand the solution. So this is the slideshow that I have created. Let me just play this. Deletion in my binary search tree. So this is the first case where you are given a tree with the root as 20. Its left child is 10, which is a leaf node, and its right child is 30, which is again a leaf node. So if in the question you are asked to delete 10, then any node whose left child and right child are null, that means it's a leaf node, like in this case, this or this. And if the key passed in this question is 10 or 30, you'll simply return back null from this place. So you'll return null. Uh, if you have hit a leaf node and you want to delete it, just simply return back null from it. Similarly is the case with 30. Moving on to the next case, suppose in the question you are told to delete 10, which has its left child, but its right child is null. So how will you go about it? If you want to delete 10 in this tree, first of all you'll search the node in the tree, and once you have reached here, you will make sure that this pointer gets updated to something like this. 10's right child is null, and we want to delete 10 from this tree. So what you're going to do is you'll hook on the parents pointing node to left its left child, as in this case. So we will hook 20th left child to 10th left child, which is 5, provided this part is null. Moving on to the third case, just the opposite of this. So in this case, if you want to delete 30 from the tree, what you're going to do is you will hook on to the parent's right node to the current node's right node, the node that you want to delete's right node, provided its left part is null, because there is no other option to hook, and hence we're only left with one possibility, and we are doing that. Next comes the interesting case, which is the in-order successor case. So what you're going to do is, this is the tree that is given to us, it's 20 at its root, and you want to delete 20. Let's assume you want to delete 20. What you're going to do is you find the in order successor of 20. How we do that? You move on to its right child, and traverse till you don't find the minimum value there in the right child. The minimum value will be traversing down to this point as soon as you encounters its left child to be null. So this is the in order successor of 20, and once you have identified it, what will you do? You will simply mark its left child to roots the node where deletion has to happen, roots left child. So you did something like this. So two's this 4 got points, 4's left child points to root's left child, as in this case, and you'll simply return this root. So the structure of the tree will be something like this: 30 here, the rest of the nodes 10, 5, 4 and its left child as we switched to 2 and the rest of the tree followed by the rest of the tree. Yeah, that's it. Because and the new tree root will become 30. And these arrows signify that there could be nodes here or not. So this is the in-order successor case that we need to explicitly handle. And now let's try and code this up. If root is equal to null, first of all you need to write the corner cases. Return null. That simply means return null. And now we'll search in that binary search tree. If root.val is less than key, that means key value is less than root value is less than key. So you need to move towards right. Root.right equals to delete node root.right comma key. Else if root.val is greater than key, now it has become greater. So what you're going to do is root.left equals to delete node and the left subtree of the bigger tree, and what you're going to do is you'll return root from here, because this subtree is the tree where deletion will actually happen and this subtree is the tree where deletion will actually happen. So whatever result you will get, you will hook on to the roots right and return the root, and similar is the case here. And the next part is some very interesting. If both if the root value is equal to true is equal to key equals to key, and now let's check if root dot left equals to null and root dot right equals to null. If that is the case, what you're going to do, the first case of us, return null. Else if root dot left equals to null, the second case of ours, return root dot right, the right portion of it. Else if root dot right equals to null, what you're going to do, return the left part of it, the third case of ours, root dot left. Else now comes the in-order successor case, the fourth case that we discussed. You need to identify the in-order successor of the tree. So what you're going to do is you'll need to find the tree next minimum node using the root dot right key. So you just move one step to the right and find the next minimum node. So this is a case when left child is not null and right child is not null. How are you going to do this? While next minimum node dot left is not equal to null, keep on moving towards left. You have moved towards left, you identify that node. Next comes our logic. Just hook the next minimum nodes dot left to roots dot left. We hooked 4 to 2. Remember that example, and simply return root dot right. Root is gone. That's it. Let me just try running this code. Yeah, I think it's same, and let me just submit it. Pass. Thanks for watching all the videos throughout this month, and I hope I will be able to continue